Okay, so good evening, everyone. Today's we are going to solve week 5 assignments for the NPTEL course Environmental Geomechanics. So most of the questions I've already discussed in the last week session for this assignment as well. But while going through the lectures, I got to understand a few more questions that could be that would be helpful if you know about them, and it would help you to okay, it would help you to better grasp the lectures. So if you look at the week 5 lectures, we know that one of the lectures is about the particle energy field, and others are about the waste generation and the type of waste, like that. So we take questions now, and if you have any question in between, you can ask me. So the first two questions are from the previous year assignments. So first is about the dredging activity. So this I have also discussed in the last class. So what is dredging activity? It is so this is taking out sediments from bottom of a lake or ocean or pond, etc. So when you take out the sediment, so when you look at any lake or ocean, the bottom sediments are rich in organic matter, right? So when you take out this sediment, that activity or that process is called dredging activity. So the question asks that what is required to do, why we need to do the dredging activities, right? So first is about the navigations channel. So what are navigation channel? These are basically uh, pathways for water flows. So for example, if you have, let's say, a river, and what you do is you are making small canal out of that river, or especially that happen in when in the irrigation system, what happen is that there is a water body, and what you do is you make small canals across your field, right? So that your fields can be always replenished with water. This process is called making navigation channels. And when we make this canal sort of structure, what we do is we taking the sediment out from this location, right? So again, it is a part of dredging activity. So this is right that it is required. Navigation channel required dredging. Another is to remove organic matter. Now, as I said that at the bottom of any lake or ocean, we have organic matter, because first we have a lot of phytoplanktons and zooplanktons, and they die over time. So when any marine organism or plant die, what happen is their remain will settle and enrich the sediment, the bottom sediment. So, and that sediment, the organic matter, is actually important for growth of future phytoplanktons or plants, marine plants. So the removal or dredging is not done to remove the organic matter, no, because organic matter is actually important for the sediment. They help in plant growth, right? And they are also helpful for any organism which actually feed on soil or sediment. For example, in beach, if you look at red crabs, so they feed on the beach soil, right? So and what they do is they take the soil, they take whatever food they have to take from that soil and remove the rest of it. So organic matter is important, and that is why dredging is not for done for that. Another is beach nourishment. So what is beach nourishment is that over time, when you look at beach, what happen is uh, any soil, right? So beach undergoes erosion, right? And over time, because of erosion, because of wave activities. Now, because of wave activities, when erosion takes place, this beach sand is going to decrease over time, right? And whatever organism feed on this beach sand are also going to get malnutrition, or they will not get their food. For that, over with time, what we do is we take the sediment out from the water body and put it along the beach to help it nourish, so that again for the because we don't want any erosion, right? Another thing is for the organism to feed on it. So both of these are important, or they are basically used important for the dredging activity. Now okay, now another question is about the particle energy field. So when sir discussed particle energy field, he discussed that there is a potential energy, there is kinetic energy. And further, what he discusses that there are different energy fields, and these energy fields are actually depend on different laws, right? And this question is about we have to match the law. So first is Lenz's law, right? So what Lenz's law says that if we have a circuit, right? Now, and a current is passing through it. In a circuit, if the current is passing through a circuit, then what happens is that the magnetic field will be in the opposite direction of it. And this is defined as that the electromotive force is equals to, sorry, not magnetic field, the magnetic flux, which is basically magnetic field for the per square inch of area. So in this, electromotive force is equals to change in flux with time, right? This is what Lenz's law suggests, that in a circuit where a current is flowing, the magnetic flux is acting in the opposite direction, and this is the hence this negative sign. So this is the formula, and it is based on what? Magnetic, right? Said magnetic flux. So what energy field we are seeing in this? Magnetic field. So Lenz's law is magnetic. When we study magnetic energy field of a system, of a geomaterial, we use Lenz's law. Next is Hooke's law, right? So what Hooke's law suggests is, let's say there is a spring and there is load at the bottom of that spring. So what it suggests is that the amount of displacement of this spring is equals to the amount of force it applied to get back up. So the force is directly proportional to the displacement. This is what Hooke's law suggests, that over time, so in the geomaterial, how we can say is that over time, how much we are displacing means we are doing compaction or consolidation. Once the pressure, like let's say in a laboratory you are applying pressure to remove for the compaction and consolidation of a soil. Now when you remove that pressure, that soil will try to get its position, right? It is also about its elasticity. So Hooke's law applies to what? Mechanical energy field. That when you mechanically try to deform a geomaterial, it will try to revert back. Okay, that is what Hooke's law suggests, and hence it is for the mechanical energy field. Another is the Fourier law. So what Fourier law suggests is that if you have a material, right, then the amount of heat or the rate of heat transfer in that material is directly proportional to the change in temperature, right? Or you can say to the change in temperature gradient. That okay. So in this, Q is equals to change or directly proportional to change in temperature, right? And once we uh, once we solve it, it is minus K, which is the conductivity. So Q is heat flux and T is change in temperature. So this is dt by dx, change in temperature uh, as the heat pass. So let's say you are applying heat here, and this is a material and it is going in this direction. So as the heat applying from one side and as it is moving towards the other side, how the temperature is changing is directly proportional to the rate of heat transfer. And since it is about the conductivity or the thermal conductivity of a material, then this is what? This is a thermal energy field. Now, so Fourier is thermal. Now what is left is coulombs, right? So Coulomb is the easiest one. What Coulomb's law suggests is that if there is two charged particle at distance r, then the force applied on those charged particle is directly proportional to multiplication of their charges and inversely proportional to the square of their distance, right? So since it is about the charge of a particle, and soil has charged particle, remember, so since soil has charged particle, cations and anions, so uh, it is about the uh, electrical field. Okay, so the answer here is B, where the so just to revise, Lenz's law is about the magnetic field. So, energy field. Hooke's law is about stress and strain applied to a soil. So it is a mechanical energy field law. Fourier law is about the heat transfer in a material. Hence, it is a thermal energy field. And Coulomb's law is about the force between two charged particles. Hence, it is an example of electrical energy field. Right. So let's move towards next question. So, which of the following is not an example of potential energy field? So, in the first lecture of this week, Sir has defined some of the uh, methods or some of the processes which are the example of potential energy and some which are example of kinetic energy. So, potential energy is that once you apply energy to an object, to a geomaterial, it is not moving, it stays in a material. Kinetic energy is when you apply an energy and it releases in another form, right? Potential energy when it stays, and kinetic energy is when you apply one type of energy and it tries to escape or it try to get out of the system, is a kinetic energy. So let's say consolidation. So what is consolidation is, in simple line, is removing water from pores, right? So if you have a saturated soil, completely all pores saturated with water, you consolidate them, you remove water out of the system, right? Another is kneading. So consolidation is actually an example of potential energy. because here the water is coming out, but the energy, so energy is pressure, right? In this you are applying mechanical energy to it to consolidate it, and it stays in a system. Hello. Hello. Yeah. Yeah, okay, okay, okay. So potential energy is when you apply, let's say, pressure. Okay, I'm just taking example. So when you apply one type of energy to a system and it stays there, right? The system is not trying to release that energy. When I explain these four, you will understand it better. On the other hand, kinetic energy is when one type of energy is escaping and is converted to, let's say, another type of energy. So in potential energy, in simple word, nothing goes out, no type of energy is removed, and in kinetic there is a removal. So in consolidation, when you are applying mechanical energy to consolidate, you are putting, so this is a soil mass and you are putting pressure on it, what will it become? So it is a saturated soil. Now after putting pressure, all the water will come out and its thickness reduces, right? So now it will not try to get back up. It will not try to get back its shape up, right? So that is how that is mechanical. So the energy that you provided to the system stays in it, and it helps in keeping its form intact. So consolidation is a type of potential energy. Another is kneading. So kneading, in simple word, like what we do with the flour in our household, so the same we do with soil. We put water to it and we use our hands to make it into a dough like structure, right? So again, once you put energy to it, or once you apply a certain type of uh, force or mechanical energy to it, it is not changing its shape. So uh, if you until you again, so its simple example is, so you have a dough, you are until you make rotis out of it, it will still remain dough, right? Until you apply any other energy to it, it will take the it will keep on the shape that it is there, right? So it is potential energy. Now vibration, the simple example is that in many of the construction site we see that there is something a sort of vibrating sort of structure which actually put over the loose sand or loose soil, so that what it does is it provides the vibrational energy to the soil, and when it does is that this soil will start taking the finer particle will go to the pore spaces of the soil. So hence it leads to compaction. But once the vibration is over, right? Once it will all the energy it will go out, and also the fine particle over the surface will also try to come out, right? So even though you apply a type of energy or vibration energy to the system cannot keep up the shape. So you cannot compact a system just using vibrational energy, right? So if it's a dry sand or a dry soil and you are applying a vibrational energy to a dry soil, it will try to compact, okay? But once the vibration energy is removed, or once this system is removed, it will again, it is still a dry soil, so the surface will try to erode itself, right? So it is an example of kinetic energy. Another is bending. So bending is that if simple you have uh, a layer and you are putting pressure from two ends and it becomes a bit curved. That is what bending is, and it will take the shape. The important is that it will not lose its shape, and hence it is again an example of potential energy, that uh, when you're applying force on two end of a system of a layer, and it is taking this curve shape. So let's say, in most of the aquifers, what happen is, or let's say in oil wells, what happen is that these are sediments, and there is a dome like structure it forms, and the oil will start collecting in this structure. Now, why this dome like structure is formed is because of the first because of the pressure that oil has put in this area, right? And even if you remove the soil from the system, sorry, even if you remove the oil from this dome like structure, it will not change its shape. This layer will remain bent only. So this is an example of bending. Okay, so only vibration is an example of kinetic energy. Others are potential energy field examples. Now, in also in the mechanical energy field, sir has also given example of them, that which of the system is for mechanical energy, and which is for which we use the electrical energy field. So one is the aging effect in soil. So to determine the age of a soil, people use electrical probes, right? And right. Another is landslide. So for landslide, first there is a mechanical energy to it, or there is mechanical deformation in landslide. Hence, the example is, so landslide is used for the, sorry, mechanical energy field is used to study the landslide, and electrical for the aging. Another is soil mass characterization. Now, if you have in the field, you cannot see a soil, right? The depth of soil. So you use different methods to determine its soil mass, uh, and they are basic. So one of them is FDR and TDR, right? They are frequency and time domain reflectometer. So these reflectometers, as the name suggests, they are reflectometers. It means that uh, a electromagnetic wave is going down the soil. Once it reaches enough depth, as you fill in the computer, it will reflect back. So that is why they are reflectometers. And here electromagnetic radiation is used. So this is an example of magnetic energy field. Freeze thaw is simple, that in the colder region, what happen is soil over time freeze, and then once the sunny season come, the ice is removed and cracks develop in the soil, right? So it is an example of thermal energy, because it is because of change in temperature. Here the temperature is low, and in the dry season there is high temperature. um, okay. So also in aging effect, we use there are different methods. I do, I don't remember. It's like one is, I think, so. In the simple term, what happen is that they use in a field. Uh, you use two electrical poles type structure, and you make a circuit, and you pass current from one pole and receive it on the other, and check the ampere reading or something, and that is that electrical use the electrical energy field in the circuit to determine the age, right? Okay. So next is that of these uh, definition, which of them is the incorrect definition? So only one of them is the accepted definition of waste. Other definitions we use generally use, but there is one definition which is basically an incorrect definition or should not be used. So first is that it is something that is generated by commercial companies due to their natural composition or quantity, and they're hazardous. So definitely waste is generated by commercial companies and is hazardous to health. Yes. Another is that it cause illness and death and affect the human health. Of course it does, but it may or may not cause, right? It may cause high damage as well as less serious illness. Last, the third is it's a any substance for which owner or the generator has no further use. It's an incorrect definition because there are a lot of things that we do not use but are not cannot be considered waste, right? For example, so it is a comparable definition. So for example, if I am not reading a book, it is a waste to me, but if I can donate that book and someone else read it, it is an important thing for that person. So waste is not something which owner or generator has no use, right? So this is an incorrect definition. And the last one is actually a definition that is used or that is supported by US EPA or UN. It is that waste except the radioactive waste which has chemical reactivity or toxic corrosive nature and cause danger to the health, right? So if you remove, so of course radioactive waste is harmful, so let's remove this. Other than radioactive waste, if there is any waste which is toxic, right, which has high chemical reactivity, is toxic, is harmful to human health, it is considered a waste, and it is a accepted definition by US EPA. Another question is about the soil stabilization. So in the last class I discussed that in many concrete industries, along with soil or along with sand, fly ash is also used. And fly ash is what? Fly ash is basically a waste of coal industry, right? So fly ash is something that is produced in a coal industry, and it is used for soil stabilization in concrete industry. Now the question is why it is used. Okay, first is plasticity modification and hence better compaction. So what is plasticity? Plasticity is that how much what after adding water to a soil, if you can make threads out of it without breaking. So that is its plastic limit. So it means that in short term, short language, what it means is that how much binding it can happen, how much two soil particle can bind with each other without breaking or without forming cracks, right? So once you add fly ash to it, it helps in better compaction. Yes. So why? Because in the pore spaces, what happen is fly ash will enter in the pore spaces, and what fly ash is also what in the last class I discussed is a pozzolanic substance. Okay, so it is something which in itself has no use, but once it come in contact with water, it has a cementing properties. It can bind so well so quickly that it helps in better compaction. So because fly ash is a pozzolanic substance, and once it is added to a soil, what it does is it goes to the pore space, and then what you are doing is you are compacting it, and it is making what, a cement like structure. It is increasing its plasticity, right? Another is CBR modification. So CBR is California bearing ratio, right? So what CBR is, it's a standard technique to determine the strength of a soil, right? And what it is based on a penetration test. So what you do is you apply pressure. So on any side you apply pressure to a soil, and then you apply same pressure to a crushed stone, right? And it determine how much CBR ratio that substance has, and also determine the strength. So when you add the fly ash, what happen is the PS, the pressure in the soil increases, and hence the CBR becomes better. Another is swell pressure. So swell pressure is that, let's say there is a you have put water to a soil to its saturation, so it becomes expand. So when you put water to soil, its volume increases, right? It expand. So once the soil expand, what happen is, now in the soil, so initially it is like this block is like this, you put water, it get water saturated, and now its size increases, right? Now you are putting pressure on it, you are putting pressure on an expanded soil, and hence if there is no space, what happen is the water in the pore will apply pressure, and that pressure is swell pressure. So when you apply pressure to an already expanded soil, the pore spaces or the water in the pore spaces apply pressure back, and that is the swell pressure. And because after adding fly ash, the number of pore spaces decreases, right? Sorry. Okay, so in the pore spaces there is more fly ash, and hence pore spaces decreases. There is less swell pressure. There is less pressure applied from the pore to get out of the system. So the answer is that all of these three things are helpful or are the reason why fly ash is used for soil stabilization. Okay. Now, one of the thing that sir has discussed is that how you define a substances or a waste is hazardous or non-hazardous. So he discussed that a waste, let's say any, even radioactive waste, if any waste is in a small quantity, right, it actually is not that hazardous. So the, okay, so this should be waste. So how much concentration that waste has, is it, let's say 1 mg, or is it 1 kg, or is it 10,000 kg? So waste is hazardous or non-hazardous actually determine on the concentration of it, that how much waste there is, and also the level of toxicity, that how toxic that waste is, how harmful it is to the human health. For example, a very simple example is same fly ash. So if you have a fly ash from the coming from the coal industry, it is very harmful to the workers who are working in the coal mines, right? But in many places, what happen is they have the this plant where fly ash that comes. Okay, so we have these sampler sort of thing where you can collect the fly ash. So there is a company called Earrings something, which actually collect black carbon from the air and use it to make ink. Similarly, this fly ash can also be collected and used for all this purpose. So for many people, for people not in coal, not related or not living near the coal mine, fly ash is not toxic. But for the people who are working in the coal mine, it is toxic. So a waste is hazardous depends on its toxicity to a person, that how toxic it is. For example, arsenic, lead, these are very toxic. Even in small concentration, they are very toxic waste. So in any industry where there is a lot of lead byproducts, right? Then even in small concentration, it is a hazardous waste. It is harmful, right? Okay. Now, there are four types of hazardous waste that actually US EPA define. Okay, and we have to find that which of the four, which of them is the type, right? So, according to US EPA, the four waste are hazardous sludge. Yes, if you read the lectures, you understand that sludge is nothing but a liquidy waste that come out of industries or mines like coal washery and something. So hazardous sludge. Then aqueous organic substance. Organic means it has some sort of carbon content. Simple. Uh, Inorganic means it's more like on the side of glass or plastic or something. But aqueous means that it is in a more liquidy manner or more has water content. So according to US EPA, of course these three are type of hazardous waste, but fly ash is not. Fly ash is actually, because fly ash is used in the industries, as even though it's a byproduct, it is used in industries. So the last one is organic, like simple organic waste is also considered a hazardous waste according to US EPA, right? So these are type 1, 2, 3, and 4. These are four types of hazardous waste according to US EPA. Now, there are methods that are discussed about the non-hazardous waste. That what, if you have a non-hazardous waste, what are the methods of their disposal? What are the methods that we can get rid of them? So, one of them is incineration. Incineration is to burn it. Now, even though incineration is a method of disposal, but it should not be done, because incineration of waste is actually very harmful. And if you uh, if you look at the papers coming from Delhi or the Delhi Kanpur region, where there is lot of, especially during the October November month. So what happened is that there is lot of agriculture residue burned in Punjab and Haryana, and all the waste act, travels along the IGP belt, and since Delhi is the nearest place, so the amount of PM 2.5, especially during the October November month, is extremely high, because whatever agriculture waste you are burning, it actually coming down towards the nearby states. Hence, incineration, even though practice, is not a good method of non disposal. Another is surface impoundments. Surface impoundments are that in many places, if there is lot of liquidy waste or aqueous waste, what happen is that they make a sort of boundary like structure. This also happens in dry waste as well. When near the landfills, they make this circular boundary. And why this boundary is made? So that the waste will not go and come in contact with other structure or people and harm them. So this is man made. So you, it's basically, you have a platform, you make a boundary around it, a circular boundary, and whatever waste you are generating, you are depositing here, making a pile. But this waste is not getting out of hand. It's still in the region. So that is a part of surface impoundments. Another is construction application. Yes. So for example, this fly ash can be used in construction industries. In the last class we studied copper slag is used in construction industries, and it isn't you in sorry, it is used in the cement industry. And then there is scrap tires which can be used in the road and other transport industry. So construction application is also important for the non-hazardous waste disposal. So these three methods are there. There are other methods that are discussed, but I just use three. If so for today I come across only these questions. If you think that there is any other question that could be there, you can tell me in the next class. And if you have any question from this session, you can ask me, because today, for today, it's okay, it's over. Which slide? Okay, yeah, okay, yeah, yeah. Yeah. Anything else? Okay, so for today, it's we are done for today. Yes, if I bend, hello, yeah, yeah. So if I bend it, it's within elastic limit, but over time, if it keeps on it stays in that position, then it reaches that limit of inelasticity, or when the elastic limit breaks, then it will not convert back into, but and hence it's not a kinetic energy example. So in the laboratory you can say that okay, I bend something and over time it gains its shape. But the example that I gave, or in the field also, it happened that it happens over time and the structure is prominent. It will not change shape. So it also happens, there is a type of lava structure. So in the earth, what happened is that there is when over after melting, the lava comes out of this surface. But because the type of soil or the type of material is such that it cannot break through this material, it makes a dome like structure. So the lava is putting pressure, or the magma is putting pressure on the earth surface. But it only can, what it can do, it can only make a bulging sort of structure. But it, until it reaches its limit and it breaks, either that happen, or until it stays like this. If this happen, it becomes a different it comes out as plume. And if it does not happen, this position or this structure will remain same. So hence it is not an example of kinetic energy. Okay, okay, thank you.